Not long ago, in a galaxy not too far away, shaped strangely like my garage. Adventures in Engineering. Welcome. Today we're going to talk about CNC thread milling using FreeCAD. It appears to be a feature that is not fully implemented or not implemented at all, I'm not sure. The manual page shows absolutely nothing. It tells you how you can contribute to the project, but does not tell you how to do it in any way. So I went and figured out a way to do it and get pretty good results, and there are a few quirks involved. So I'm going to spend this video telling you how to do it and get your own good results. Let's get to it. Thread milling is cutting threads into a part using your CNC machine. So when you're done, you have a threaded part that just works. You don't have to retap it, you don't have to cut a hole and then tap it later. You just make it part of your process. A thread milling bit looks like this. This is a single flute or a single tooth thread milling bit. And this is a really nice bit because it allows you to do many different thread pitches. This one happens to be, I think it's about 3 millimeters thick here and 4.9 millimeters thick at the edge of the teeth. So the smallest I'm doing millimeters, so the smallest I can do is a 6 millimeter thread. However, I can go, I think, all the way up to 10 or something like that with this same bit, and of varying thread pitches. FreeCAD 21.1, and I tried the same process in 20.1 also, and the same problem occurs, but I'm going to show you how to work around it. First, we're going to start by making a very simple part in order to refine the process. So create a body, create a sketch, make it on your XY plane. For the CNC machine, I want it on the XY plane. And so very basic stuff. We're going to start with a circle at the origin, and then a square around that, which is going to be essentially the material that we're cutting out of, and then we're going to extrude it to a thickness that the part will be. You'll need to know the dimensions for your model, and you get that from an ISO thread chart. In this case, I'm using metric. I'm going to do an M6 by 1 millimeter thread pitch, and so the internal thread, which is a bored hole with threads on the inside, has an inner minor diameter of 4.9 to 5.15, and then an outer of 6 to 6.29, which is 6.3. They say to tap it at 5 millimeters, but I say tap it at what you want your minor diameter to be. So in this case, I'm going to go with 5.2 just to make it reasonably loose, and so the threading tool doesn't have to do as much work. So I will start with a 5.2 bored hole, and then I'll use the threading tool to cut it out to 6.2 or 3. Dimensions, I'm going to use diameter of 5.2 as the chart showed. And then these dimensions out here don't matter that much, but you need to have them. And you want to extrude this to the thickness of your material. I'm using a test material that I know is about 13.5 millimeters thick, so I'm going to use that. And that's done. Now on to the part where we're going to make this thing do actual thread milling on the CNC. So you want to go to the Path workbench, and we're going to add a job. Okay, and I'm just going to use all zeros around it, no extra padding, because I know that I've got the right thickness for the material, and I want it to cut from top to bottom on that material. And I'll show you, this is just taking away, you can see all the space, added space around it going away each time I put a 0 in. And you can set an output file. You need to set your output type, in my case, Gerbil. And then let's see, set up, you want to add your tools to this. So I know I have an 1/8 inch single flute that I'm going to use to bore the hole, and a Threadmill tool bit. I'll show you how to make the Threadmill tool bit in a little bit. Okay, work plan, we don't have to worry about that. We can set the output file if we want to, but you can do that later too. Now we're going to create the Threadmill tool model. So you want to go and open up your Path workbench, and then under Path, you can go to Toolbit Library Editor, Create Toolbit, and then you're going to pick, there is actually a default for Threadmill. Open that up, and then you can save it under a name. I'm just going to go Test Threadmill, just to show how this works. And then open that up, and you can see how you're going to edit this thing. So there's neck diameter, neck length, shank diameter, and then there's the diameter of the tool bit part of it. So that, you'll set all these things to what the information is. And here you can see a little picture of it, the single single tip there for doing different thread types. Cutting angle, it's typically 60 degrees. And then you're just going to put in all this information and save it. And then you'll have yourself a Threadmill tool that you can select to use the way I showed you how to use it before. Now, we need to add a helix. And this is going to be the bored hole first with that 1/8 inch end mill. So the depth, see how my start depth is 13.5 and the final depth is 0. Step down of 3. I don't want to step down of 3. That's too much for my tool, my machine. So I'm going to go with 0.3. Yeah, it's slow, but it's clean. Then we go to heights. I don't really care. That's not really important to me at the moment. I want to start from the inside, not the outside. Step over percent, and extra offset is 0 because we know the central bore is the right size for the tap hole. So we apply that, and you can see the helix that was created by that. So now we can go and simulate the job. And you can see it basically just drills down in and creates the hole. Next, we want to add another helix. And this helix is going to use the thread milling tool. Again, we want it on the inside. In this case, we're going to have it cut larger than the hole, which somewhat counterintuitively, we say you would give it a minus offset. So that's going to be minus 0. I'm going to start with 0.3. Apply that. Remember that this offset is going to be half of the difference between the inner and outer part of the threads. I only want to cut half of it at a time, and that's actually half of the total width between your subtracting the inner and the outer diameters. And then you'll want to cut it in increments that your tool can handle. And in this case, it's going to be about half of it. So then for depths, you want your step down to be your thread pitch. This is very important. So in this case, I'm using an M6 1.0 thread pitch. So I want this to be 1.0. Side clockwise -3. Okay, apply. See how it created a spiral slightly bigger than the spiral that was there before. Okay, now this tool, oh, I chose the wrong tool. Let me apply that with the Threadmill tool. Okay, now it ends up actually smaller because the outer diameter of the tool is bigger than the outer diameter of the tool we're using to um, bore the hole. So now we have a spiral with the thread milling. So let's go with that. To be able to visualize the cuts, I like to go and change the appearance, add transparency to it. 40% makes it pretty easy to see. There we go. Now we can see through the part a little bit. So let's look at the front. And if we click on the helix here, now we can see that thread mill part spiral highlighted. Note that it starts on the right side of this, what looks like a sinusoidal wave, but it's really a spiral. So now we can count. We can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Well, I know that the part was 13.5 millimeters thick, and it made exactly 14 spirals into the part. So that is not 1.0 millimeter pitch. This appears to be a bug with FreeCAD, that it's sort of overriding. It's making an equal number of spirals for the thickness of the part. So what you need to do is add to the thickness that you intend to cut the spiral in. So what you do is you come in here and you say, and you probably want to go to a final depth lower than the part anyway, but you also need to bore the hole out deeper than that if you're using a foil board also. So in this case, let's say we're at 13.5 for the thickness. So we want to go to minus 0.5. And that will give me 14 millimeters. So that is a multiple of the thread pitch. Okay. And then apply it. Now look what happened to the spiral. See how it starts on this side here, and as it exits the part, it's on the other side, the exact opposite side. That is correct. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and a half in a 13.5 millimeter part. Perfect. Now we have this, the threads are going to be the correct pitch. So that is how you do it. You make sure that your start depth and your final depth equals a multiple of the thread pitch. Now I'm going to go back and make sure that my original hole has the same thing done to it. In this case, I'm going to go minus 1.0. It doesn't matter if it has, an equal number of spirals as it goes down through, because really we're just cutting a hole and the sides are all going to be smooth anyway. So the step down, yeah, okay. So now we apply that and you can see it's going 1 millimeter lower, and that gives room for the threading tool to go down 0.5 millimeter lower. This is a helix tap hole. It's going to be the helix thread 1, because the first thread hole. Okay, and then we're going to add another thread hole, which is going to be essentially the same thing, but with a larger diameter to get to the final thread pitch diameter. So add a helix, change the depths again. So again, we're going to go minus 0.5 to make it a multiple of the 1.0 thread pitch. So now we have 14 millimeters, 1 millimeter thread pitch. The operation, we got thread mill. That's the proper thing. We need to make sure it starts on the inside. We want an extra offset now to be minus 0. And that will give us the second cut, which will get to the actual final thread pitch size. Apply it, and you can now see that this one is a little bit smaller than this one. You can see the thread pitch on the inner one and the thread pitch on the outer one that got a little bit bigger to cut to that final size. And they track each other exactly. So your high point, or your high point of the sinusoidal looking wave ends up being lining up with each other. Okay, so again, I'm going to rename this so it makes sense. Thread 2, okay. Okay. So now the next important thing is we want to simulate this. So let's go back to an isometric view and do this. Ready, go. Okay, boring the hole. Changes the tool. You can see the width that it cut here now comes back up and makes a bigger cut. Okay, and this is your spiral. This is making the threads. It doesn't really show the thread on the cut look of the part, but you can see based on the tool what it did. Okay. Usually hit cancel. If you hit OK, you end up sort of leaving this brown part of the. I'll show you what happens when we do that. If you hit OK, see how it stayed brown? What happened is it saved the cut material, which you don't really want it to do that. So it's a good idea to just hit cancel when you're done with that. So let's delete the cut material, and so we can see the part as it's designed. My CNC machine does not have an automatic tool changer. So the way to do this is to do it in two different files. So the first thing you want to do is this little pulling looking thing toggles the activation of the operation. So you want to first disable the threads and just create a file that has the tap hole. Okay, so that is going to look like this. See how it only shows the tap hole. And that is the complete operation done in what's going to be the output file. Okay, so then you create that output file with post-processing, and I've called it Threadmill 1 GCODE. Okay, and that showed up on my other screen. So now you can see what it's doing here in its spiral. And this is important when we look at the Threadmill one too. So it starts at 13.5, and then it's going to spiral down, all of these half circles down to the bottom of the tap hole and end up at z equals -1. Okay, that looks good. Now we're going to disable that one. We're going to enable thread 1 and 2. Actually, I'm not going to enable thread 1 right now. First, I'm going to open up thread 1, and we're going to change this back to 0, just so I can show you the problem you will encounter if you don't make it an equal amount of the thread pitch. So we apply that, and we're going to go and look at the output file. Call it 2. Okay, And this is where you see the problem. See how z equals 13.018, 12.536, 12.054, 11.571. See, these are not multiples of 1 or 0.5. So this is why the threads won't work. It'll thread in a couple of the first two or three threads, and then it's going to start getting tighter and tighter, and then it's just not going to work anymore. So we're going to cancel that. We go back in here and we put it back to the minus 0.5 to give it a multiple of 1.0 thread pitch. Apply it. Okay, and now we go and look at that same thing again. Sure, replace it. Okay, now look at this. Okay, z equals 13.0, z equals 12.5, z equals 12.0. And we end up going down to 0, 0, minus 0.5. So this is going to give you a correct thread pitch, because now we're in multiples of 1 for these full turns. Each one of these, I believe, is a half circle. And so it's going half a circle, 0.5, half a circle, 0.5. So you'll end up with a 1.0 thread pitch. That is correct. Now we're going to enable both of the thread milling passes and output that as a separate file. Again, we want to call it Threadmill 2. And so we're going to have Threadmill 1 and Threadmill 2 G-code to run on the CNC machine, and we'll change the tool in between running the two files. Yes. So now we can look at this. We can see that X and Y. Yeah, so let me make sure I've got the Threadmill 2, the second one, that I've got a proper depth. Minus 0.5, yes. Okay, now we're ready to cut. All right, I'm starting this process with the 1/8 inch bit, and I'm just going to move it over and zero it at a hole that's already in this piece. This is just a 13.5 millimeter thick piece of plastic, just a leftover scrap, but it allows me to refine the process of making the threads. And then when I go on to a real part, I don't have to, worry about ruining it. I've already sorted out my process. All right, I've set my X, Y, Z where I want to have them, and I'm going to go and set this as my home position. So now it's 0, 0, 0 on the X's, and then I've got to go and zero the Z axis with the probe. All right, now we're going to load the Threadmill file. Threadmill number 1, G-code. And it's ready to go. Whoops. Big mistake I made. I forgot to put in the speeds for the bits. In FreeCAD, it doesn't automatically fill those things in. So I've got to go fill in that it needs to spin at 12,000 RPM and what the feed rate and horizontal and vertical feed rates are. So let me go add those in. All right, so this is a minor annoyance, but something you got to do every time. Got to go into the tools and set the feed rates and spindle information. So in this case, we want 12,000 and find 300 works for me. Whoops, not 3,000, 300 vertical feed. I'll just set it at 100. In this case, doesn't much matter. And that is that one. Now we go to the other one, fill in the same information. Okay, now both of them have the correct information, and so now we need to go and recompute. I think, I'm not sure if we actually have to recompute this or if it automatically did it, but I do it anyway. Recompute object, and now we can output the file again. So, all right, starting over again with the proper file. And I'm going to change over to the thread milling bit. Okay, now we're going to test this thing. This was the hole we just did. And, oh yeah, threads right in there, right on through, no problem. Got a little bit of sawdust up in there from the drilling down into the spoil board. But that's okay. Easy to clean out. And you can always do this over a gap, or raise up your piece so that you don't have to drill down into the spoil board. Anyway, nice looking threads, and they're exactly as advertised. So there you go. That's how you thread mill with FreeCAD and your CNC machine.